Hello everyone. I'm covering YouTube system design interview questions. This is a rough sketch of how YouTube works. A user uploads a video, then the API receives it, and which is stored in a blob. Okay, and from here we pass the blob URL because since video files cannot be stored in SQL database, they're stored in S3 buckets or GCS buckets, things like that, and it goes to a message queue for a synchronous processing. So this is the transcoding phase in which the video is broken into smaller chunks, then they are transcoded into various codecs and resolutions, and from here they are again reassembled. Now for faster delivery, this video is then um, replicated in other region to reduce lower to lower the latency, network latency. So we have NoSQL database which stores the like counts, subscriber counts, things like that. But still, um, one doubt that is still unclear to me, which is where do you place the SQL database? So I'm using Claude to study YouTube system design, but the problem is, Claude just keeps giving you more information. I want to put a full stop over here and first go through this question. Where is it? So I'll say, okay, let's move on to the third question. Question 3, read and watch path scaling. So we have nailed the right upload path. So this entire flow deals with writing uh, to a database, but then how do you read videos and give it to the end user? So you have nailed the, now let's flip to the read side, which is where YouTube spend most of its engineering effort, because obviously YouTube is read heavy. So a user in India opens a video that was uploaded by a creator in US and has already been transcoded. Walk me through. So what happens step by step from user click play to video start streaming? Where does the request go first, and how does the okay, so since these are very important points, I would like to note them down, and I'll again revisit this same question over and over again so that my understanding becomes clear. And also uh, this is a very simplistic architecture of YouTube. Over here I haven't mentioned cache, um, and this is just specific to read. So first individually study the components and then integrate them and study the entire system. So read and so the question 3 over here is Q3 is read watch path scaling. So why it's important to optimize read operation, because YouTube is read heavy. So now we have given a scenario where a user from US uploads a video. My E key is not working properly. I need to fix this. User uploads a video and a user from India watches it. So explain what happens. So the first question that I need to explain is what happens. Where does the request go first? What happens if the video is not yet cached in India? CDNH, cache miss. What's the fall path? You mentioned it earlier. How does the client actually decide which resolution to request and how does it switch? Take a shot. Even partial answers are fine. We'll build it out together. Okay, so I'll first answer my question. For the first one, I think uh, first it looks in the CDN. If not, then the request is forwarded to US region, and from there uh, I don't know. I don't know answer these questions. I don't want to like I don't know. No worries. That's one generally harder and less intuitive. So play stream step by step. So when a user clicks play, the client browser requests a video manifest file, not the video itself yet from the manifest for adaptive streaming. It's an HLS or dash MPD file. List all and where to fetch each chunks. Okay, so the CDN gives you the manifest files, not the actual video. And starts the resolution, requests the first few chunks from the CDNH. CDNH serves chunks directly if cached, no original server involved at all. Cache miss. If the CDNH doesn't have it, it makes the original pull. Fetch the chunks from the original blob storage wherever the transcoded output lays. First viewer in that region pays a latency penalty. However, everyone after gets the fast cached path. This is exactly why popular trending videos warm up. CDN sometimes pre-push predicted popular content to edge proactively instead of waiting for a miss. Then we have the adaptive bit rating. How do you decide which bit resolution to send? The client continuously measures its own download throughput, how fast recent chunks arrive. Each chunk is typically 2 to 10 seconds of the video. Before requesting the next chunk, the client ABR algorithm decides network looks fast, buffer is healthy. Because chunks are independent files per resolution, switching is seamless. No restart, just the next chunk comes from a different quality tier. The don't hammer the DB part. You never do update video set synchronously on every play. Under viral load, that's millions of write per second, tracing one row. Huge log contention. So instead, play event push to a message queue, a separate counting service. So check your understanding. Quick questions back to you. Why does it matter that video chunks are small, a few seconds each, rather than CDN caching serves one giant file per resolution? What does the buy us specifically for the ABR switching? No clue what ABR switching is, to be honest with you. So really good explanation. So I'll note everything down. Play, stream, how does it work? First I'll write the text and then in my own words and then I'll draw a diagram. So the user clicks play, the user clicks play, the Browser request the video manifest file. Request the videos manifest file from the nearest CDN edge server. Then the manifest for adaptive streaming. It's an what I'll do, I'll open another tab and I'll ask what does this mean, because I don't want to like scroll up and down to what does a manifest is basically an index file the video player downloads first before an actual video data. Okay, so the manifest file lists the different resolution and qualities. The best one for the viewer is decided by their network. Points to remember where the chunk file is. Video isn't stored as one giant file, split into smaller segments. Concretely, LHS used by Apple, many others, a master playlist list where variant playlist one per resolution. XML describe adaptation sets, example videos, audio subtitles. The different resolution which each segment refers. So the flow is play, request the manifest, sees available options, picks a resolution based on current bandwidth and buffer health, request the segment URL for the resolution, download chunks sequentially. If bandwidth changes, it can switch to a different resolution segment starting from the next change without restarting the playback. This is why platform like YouTube can seamlessly downgrade you to 360p on a bad connection without the video stopping. The manifest already told the player where to find the lowest quality chunks. Okay, request. So the manifest file is basically an index file pointing to the actual video. Manifest. Yes, essentially, but more like an index of indexes than a direct pointer to. A manifest itself contains no video data, it's just plain text XML with metadata. Then the player reads the manifest once. Okay. Index of indexes, then a direct pointer to one video file. The manifest itself. Okay, so the manifest file points to the multiple version of the same video. So if a video is 2 hours long, so it will point to all the chunks for that video in the manifest file. For each resolution. Okay, damn. So a manifest file is um, like an index of indexes pointing to the various resolutions and the chunks. Client picks a starting resolution, requires the first few chunks. CDN serves chunks directly if cached. Okay. So once the client knows where the video is, so it requests it from the nearest CDN edge. So if cache hit, then serve directly, and as a result it offers low latency. Now the scenario is cache miss. The CDN server doesn't have the original video. So it makes the original pull, fetch the chunk from the original block and cache it locally. First viewer in that region pay a latency penalty, and everyone from there then get the cached version. Okay. Uh, Take a pull from original blob storage. So the first user pays a latency penalty. After that, all users uses the cached version. Now the third one is adaptive bitrate client logic. So the client continuously measures its own download adaptive bitrate. So adaptive bitrate is a client-side logic which helps to evaluate, okay, which resolution can the client current network supports. So adaptive bitrate is something like change to a different resolution based on network strength. Yes, exactly. That's the core idea of adaptive bitrate. Okay, adaptive bitrate streaming. The player continuously monitors available and buffer health. Based on that, it decides the resolution for the next chunk. If your network suddenly gets worse, key details that make this work: switching happens between chunks, not mid chunks. All resolution are time aligned. Chunk 47 of the 270 240p track converts. So I think adaptive bit rating itself is going to be a completely different component which I would like to pick next to understand how it works. Each chunk is typically, so what is the question? What happens if a video is not yet cached? So I will copy this question. The second question is what happens when a cache hit takes place. The third one is adaptive bitrate. You mentioned earlier, how does the client actually decide which resolution to request and how does it switch mid-play if the network conditions. How would you handle the view count update the video without hammering your database on every single play? So I will say ABR stands for adaptive bitrate streaming, you know, based on the client's network strength. Decide which resolution to serve without starting the playback from the beginning. Okay, so how does it happen? So client monitors its download throughput download throughput, that is how fast recent chunks arrive, how fast the recent chunks arrive. Each chunk is typically 2 to 10 seconds. So before requesting, the client ABR algorithm decides, okay, each chunk is 2 to 10 seconds long, and before requesting, the ABR algorithm computes which resolution to send next. So because chunks are independent files per resolution, switching is seamless. Okay, because chunks are independent file per resolutions, switching is seamless. So no restart, just the next chunk comes from a different quality tier. So no restart, just the next chunk comes from a different quality tier. Okay, so the last point is don't hammer the DB. So never do, but rather all the counts are pushed to a message queue, and from there they are batched together, and in one go the count is updated. So the fourth one is so the counts are not updated every time a new viewer arrives, the count is pushed to a sync message queue, and after some time in one go, the count is updated. If so over here I can add one more point. So for viral or trending videos, it can hammer the DB multiple times for the same row, causing serious contention. Therefore, two viewers can see different view count, since it can be stale, because availability is emphasized over consistency. Availability is emphasized over consistency. Emphasize. Okay guys, thank you so much for watching. In the next video, I don't know what I would like to cover. मेरा गोल था कि मैं जान क्लियर करना चाहता था यहाँ एसक्यूएल का डीबी कहाँ पे होगा और उसमें कब रीड एंड राइट परफॉर्म होते हैं. सिमिलरली आई वुड आल्सो लाइक टू अंडरस्टैंड कि जब जो हमारा नो सीक्वल डीबी है उसमें कब रीड एंड राइट परफॉर्म होते हैं. So mostly pertaining to database I will cover in my next live stream.